Thank Paul and the BSides crew and Adrian for recording all this. This is a great venue, and I really like the location too. I'm going to go ahead and start my talk then. So my goal for this talk is to kind of give you a technical understanding and history of WRT firmware and mesh protocols. Basically break down as much terminal technology as possible, but not to bore you. I like to put kind of weird, funny slides in there every once in a while to keep things interesting, because I see too many talks that are like the professor I hated at college. That's all technical and then, not as much fun. So this actually came from one of my talks for system hardening. And ever since I did that talk, I kind of have to have either a dick joke or a Pokemon reference in my slide, and that has actually both. So who has a router with aftermarket firmware on there? Whether it be OpenWRT, DDWRT, Tomato, or whatnot. I was actually hoping to find a router with a giant spoiler on it, but that heatsink did just as good. So let's talk about the modern day benefits of routing firmware. First start with this actually kind of happened somewhat recently. Who heard of a thing called Joel's Backdoor? It was a part of D-Link. D-Link actually had a bypass in there. So usually you log in through a router through a username and password, and inside that somebody ran IDA on it and kind of did an analysis of it and saw that there's a string. Oops, wrong button. What did I do there? There was a string on there, and basically it had this thing on there where it says XML set. Basically in there was a hard-coded password, and it basically spelled out Joel's Backdoor backwards. That J-O, whatever, they're right there, spelled backwards. And so they found that pretty much anybody could bypass the actual authentication on a router. So if you're like a malicious person sending an ad campaign and you're visiting a website and you're able to bypass that through the website, you basically get root access to the router and do certain things with that maliciously. So that became kind of a big crave for a while, that people were trying to look more and more into router firmware, see which ones have backdoors, and they found more on like Linksys had a few. Netgear actually had one famous a while back. The interesting thing about this one, though, that this was founded in 2011, but I think it was in 2008 they saw on a Russian message board that basically had a posting of that exact user agent string. Another one that happened recently, which we probably all heard of, is Juniper had a backdoor. Even though I don't want to say this, but kind of props to them for being so clever on the backdoor. It actually looked like just a debug code going into that. But, pretty much still, if the backdoor is horrible that they do something like that. But in actually writing this talk, there's also been Fortinet found an SSH backdoor. It's kind of becoming more and more of a common thing. There's actually an extremely large list of exploits, not just like backdoors, but buffer overflow attacks that sometimes the vendors patched already. They're notified and addressed. Sometimes vendors are like, well, that router's end of life, even though people use it on their network. We're not going to do anything with it. So that's routerpwn.com. It has a huge list of things that you could go on there and find out, what could be vulnerable on your network. So let's talk about some of the benefits of aftermarket firmware, which majority of them, or pretty much all of them, are open source. The benefit of the open source is that, jumping ahead. The benefit of the open source is that you get the capability of seeing the source code. So if there is a backdoor that's placed in there, you could see it. It's not going to be where you have to do it through a hardware, or a file level analysis of what's going on with that. The other benefit with open source, especially in like platforms like OpenWRT, they're very proactive with vulnerabilities. When Heartbleed came out, and this is a couple of years ago, but when Heartbleed came out, how many people had to wait for their vendor to patch their equipment for like a day? To patch their equipment, a week, year? No, okay, months, okay. But either way, it sucks because you're relying on another vendor for that. OpenWRT, once they had that, you just update it through their package manager. Just OPKG is kind of their package manager. You just do update and then run install OpenSSL. So the benefits of updating your firmware for like home use or something to make it a little bit more enterprise, will give you more security purposes. When you update the firmware, you get get rid of that standard home use router to more enterprise. You basically get your VLAN access. You could basically do VLAN tagging of all the four, like most routers come with like 4 ports for it. All 4 ports could be tagged whatever VLAN you want. You got IPsec, you got your VPN, open VPN access, WPA with Radius, so you could actually pipe a database through there for user authentication for each WPA session. IDS, your snort rules, and then IP tables or NF tables, whatever it's called now. So other features, you basically could increase your radio transmission power. Not a big fan of that though. Generally, when you increase your power of your radio, you tend to actually get to the point where you're kind of heating up the IC and you're going usually out of the spectrum of what you're sending for data. That's kind of what FCC really doesn't like either. But you get also advanced quality service settings on there. Some of the stuff, especially like the Tomato firmware, the graphs are amazing, really easy to look at, really easy to configure. You got a better web interface, so if you want to go through there, it just looks a lot better. You got your NSF, the CIFS share, so if you want to do a file share on your Windows network, you have that capability of doing that through the router. Web server, so some of them even have NGEX servers on them. Hotspot support, so if you're logging into it, like you go to McDonald's, you log in, type in your email address, then it'll give you a DHCP lease. You got your USB storage, USB air card, USB print server, and UPS support. So an interesting thing about this is that you even set up your router at home, have your UPS on there. If power goes out, it'll send you an email. The list goes on. It's literally just a full-fledged Linux operating system inside your router. So how did this WRT come about? It basically started with a GPL violation. It's kind of a funny slide there. So basically, between Seattle Wireless and the Linux kernel mailing list, they kind of, this is the actual posting, don't worry about reading over that, I'll explain in a second. They basically started poking and prodding Linksys about the fact that they saw in the firmware file, the bin file that they download off their website, it has a Linux kernel in there. Then he noted the version was like a 2.54. It had other GPL or GNU licensed software like BusyBox. It was using CramFS file system. So they knew that they're using this open source code, but they never saw anything released. And so they kept poking and prodding them. They sent him an email, and the guy replied back, yeah, we do that. And then he replied back, well, can I have some more information? Who did I talk to about this? Goes dead for about 3 weeks. Another, a week goes by, and he's like, I don't think this guy's going on a week vacation, so he's emailing PR at Linksys. Basically what happened is that guy is like, don't talk to him anymore, we're going to get sued. So they're all fearful. GPL violations was kind of a newer thing in 2003, so they didn't know what to do with that. So, and Linksys was also kind of a smaller company at that time. So what does any company like that at that time do? Kind of freak out and just kind of throw it out there, the whole source code. Usually with the GPL violation, you don't actually have to give, like if you do a GPL violation, you don't have to say, hey, this is all the stuff I have in my www folder in my website. That's not part of that. You only have to actually send what you change in the actual source code. So if there's some like configuration files that are separate that are nothing part of the source code, you don't have to do that. Linksys ended up giving all of it. So how they did with their their web portal and how it communicates with the actual low-level part of the kernel. And they also released, which was a huge benefit, their actual hardware in there, like the Broadcom drivers. So how that works. So instead of reverse engineering the Broadcom drivers, they had that pretty much just handed to them. So it was all open source at this point. So that essentially started a kind of a bandwagon effect. Everyone started jumping on board. They all wanted to create their own version of a WRT firmware. They liked the fact that you could run a 4 meg Linux operating system that has all the router capability features and whatnot. One of the earliest contributors was Sevstov. He started with a lot of the implementation of like IPsec in it, OpenVPN. He did some like later on work with like mesh support. You can see this is actually one of the early ones. This is the, I think, Talisman version, but it looks exactly like the old Linksys firmware when you would log into it. Eventually, though, over time, they changed the actual web interface. This actually looks like something else. If anybody uses DDWRT, this looks a lot like that because I'll explain in a few why. But Sevstov was notorious for being a complete dick. He ended up at one point, because he took open source code from Linksys and then, re-edited it and released it, but he also tried to make it a business off of it. So he took free code, then closed it off by using a wallboard on his, like a wall block off on his website, saying that you got to pay a $20 a year subscription. And that pissed off a lot of people in the open source community. And they were like, so you're just taking somebody's free code and then making money off of it. So a lot of people took that actual firmware dumps or the compiled version of that code and just putting on various websites, and he would actually threaten them, and it was really bad. He also, at that time, there was a lot of peer-to-peer networking that was shared on a lot of that stuff, and they ended up like your email, EDK, stuff like that. And he ended up putting like corrupt files in there and overwriting some people's versions that they dumped for free. And then it was just literally, and this is what it was, is that you would go to the address 192.168.1.1 after you flash it, and it would just be this page, nothing else. So he purposely sabotaged a lot of the firmware. But I ignore a lot of that stuff too, because he contributed a lot and started the WRT firmware. Essentially, the whole WRT firmware became Linux 2.0 in a way. It was like the small embedded version of Linux that became its own distro in a way that everyone based off of. DDWRT was or Brainslayer was one of the people that started DDWRT for the sole reason that he was pissed off at Sevstov, and then created his own distro, took his own source code, and started developing on top of that. That's why Talisman, like that, looks a lot like DDWRT, because they actually use the same exact interface. Here's a list of the kind of the big contributors. You got your Sevstov. DDWRT kind of was based off of that. Wi-Fi box was kind of added a lot of customizations, which really wasn't well known at all. It was one of the earliest ones, though. Earthlink was kind of interesting. Earthlink, smaller company in 2006. They wanted to switch over IPv6. They probably didn't have a whole lot of money because their whole company was based off of dial-up. So they're like, how do we go, convert over IPv6? Well, let's just use take the code from the Linksys router and put IPv6 on all this stuff, so you don't have to write anything. It's kind of an interesting thing with like corporations and how they utilize it, open source code for that. Hyper-WRT, which is known a lot now with Tomato firmware, if you guys ever use that. And then OpenWRT is kind of like the kind of go-to for that. All these ones are based off of it. You got Gargoyle, DDWRT, XWRT, Robin, which is basically a mesh based OpenWRT variant. Kiro WRT, Oleg, which ended up becoming the Tomato USB. I'll explain a lot more of these variants here. So your modern day branches are like Tomato firmware. I actually like Shibby Tomato firmware a lot. It's an easy learning curve, and I'll show you a picture of the AJAX interface for like the quality service graphs. It's one of the best looking web interfaces. The only problem is it supports Broadcom only. So if you have like an Atheros, Qualcomm, Rylink, any type of other chipset on there, will not support that. It's very full featured. You have literally everything you want on there. But it doesn't have any mesh support, and the package manager is kind of lacking. OpenWRT is supported pretty much the majority of the chipsets out there. It's one of the most developed ones out there. Has full mesh support, which I'll explain later on some of the mesh protocols. Large library package. The package manager is kind of based off of Debian. If anybody's ever used apt-get, it's exactly like that. When you run OPKG, you do an update to actually sync the repository. And this one has additional support for all of your advanced stuff. You have IDS on there. You can install Snort on it. Technically, even if you want, you could install higher level networking protocols like BGP on it. But why would you want to run BGP on a 240 megahertz MIPS processor? Your guess is as good as mine. These are some other ones. WRT, it's I call it noob friendly. You probably heard of it. A lot of people like to install that. It's kind of their first thing they install on their router. It's kind of bloated, and it's not really as good as I like as the other distros. Gargoyle is very cool because it's, for somebody just getting into it, it's very simplistic, supports all the chipsets. It's based off of OpenWRT, so it has all that support, and it's really easy for bridge mode. So I'm going to talk a little bit about OpenWRT because it's kind of my more favorite. OpenWRT, you can see all the different versions, starting from 2007 into currently right now, Chaos Calmer in 2015. This is kind of like the changes of it. This is like the first version that was kind of released as White Russian. If anybody can notice this, if you guys in information security, you should probably notice the names of them, of OpenWRT firmware. They're all names after alcoholic beverages, which kind of goes together with anybody in IT and information security. So you got your White Russian, which was kind of like the earliest ones. It looks exactly like Linux's firmware. Eventually they updated. There was a project out there called Lucy, which is kind of like the web interface, and ended up updating that and make it a lot easier and more dynamic. And then you can see in the newer versions how much better it looks. Kind of got the Mac appeal in a way, but it's really easy to the eye and easy to configure. XWRT was a variant at that time of OpenWRT when they were testing the Lucy. This used WebF, which was another kind of a cool thing that at that time they weren't decisive of how to make the web interface properly, so they had other people compete, and it's kind of, you know, how the things in the open source evolve. It's kind of interesting how that works. Gargoyle, you can see how very simplistic this is. And then this is Tomato firmware, the quality service graphs. There's a lot of cool features in there, like IP limiting, so you could actually have a device per network, IP limited, and a bunch of other things. Other free, or when I say free, I mean free as in freedom. So kind of making a little echo there. About free as in freedom. You have pfSense. Probably a lot of people have heard of pfSense. Anybody? I see some heads nodding. That's based off of MonoWall. It's a BSD based. It's very useful in enterprise. There's a lot of capability. It's x86 support, so you won't run it on like more embedded processors. Linux also has one very similar to that called IPFire. It uses actually hardened Linux kernel, so it's a lot more secure in that sense. Other partially proprietary, so there's like a lot of closed source binaries and closed source information on there. Linux-based Viant was very common in a lot of enterprise ISPs. It's actually used in Brocade, and also like I think Ubiquiti uses it on some of their routing equipment. RouterOS is Microtech. It's used in a lot of wireless ISPs. JunoOS, Juniper, which is BSD based. VxWorks, which is a when Linksys got pissed off about Linux trying to sue them and all that stuff, they ended up going with another provider called VxWorks, which is just another small embedded kernel, and they rewrote everything in there, and it was only 2 megs, so that was basically their way to compete against Linksys or Linux at that time. And Cisco has 2 different kind of flavors of their routing. Well, more than that, they got Catalyst too, but for their routing equipment, they have the iOS and the iOS XR. The interesting thing about the XR is that the reason why that exists, which is QNX based, is because the iOS kernel itself did not support preempting, so it was run to completion. So in order to do like high availability and failover on the high-end routers, they needed something a little bit more higher end of, well, not higher end, but something for multi-threading and processing for the kernel, which the standard iOS did not support. So they switched that over. Noted WRT contributor, which is kind of more recent, about like 2012, the project kind of started up and blooming. There was a project called Buffer Bloat. Essentially, network schedulers were having a lot of jitter and delay, just by default the way they're designed. A lot of them were first in, first out. So you had prolonged queues, excess delay, which also creates throughput issues, slowness, unnecessary CPU cycles. So they came out with a thing called CODEL, which is controlled delay. It was kind of a mathematical approach to creating a network scheduler. Really very advanced stuff. When they tested it, they didn't just test it in a small environment. They worked with a bunch of ISPs, and still getting that echo. They worked with a bunch of ISPs, and they worked with different things like DOCSIS, your cable modem, DSL, and wireless, and all these different things to get the best approach for that. And I would say almost an overall efficiency that they gained out of it was 10%. When they worked with all these different vendors, they ended up kind of helping them deploy all this stuff. So globally, they almost saved like 10% on network efficiency, which is really cool because if you think about how much network traffic that is, it's a lot of energy they save. Another thing is that there's a lot of IPv6 projects that kind of came about from the OpenWRT and some of the other WRT firmware-based things. HipNet was basically, which you'll start to see, sadly, with the Internet of Things that push a lot of IPv6 protocols that kind of utilize automation. So that's what HipNet does. It's a home automation, IP video, smart grid. It's self-configuring packets. Another one that came out of that was HomeNet, which basically kind of a minimalist, kind of a synchronizing protocol, but it also uses public and private key type length variables. Not really crypto, but it keeps with the actual syncing. It's kind of a cool concept. There is another one called CJDNS that does full-on crypto, part of the actual networking protocol. The actual hashes of the data coming back and forth is all cryptography. It's really cool. Another thing is with the whole WRT movement, there was a lot of these people like in OpenWRT that worked on other projects like DNS Masquerade, DHCP. They saw these things need to be fixed, so they worked with them and sent it back over. So it was like a big community that helped push Linux in general, which everyone else benefit from. So let's talk about mainnet, and this is the second part of the talk. And this kind of incorporates to a lot of things that the open source community contributed to. Mainnet stands for Mobile Ad Hoc Networking, RFC 2501. It came out in 1999. It was a combination between University of Maryland and the Naval Research Laboratory. Basically, it's the concept to drive mesh technology. A lot of the RFCs are generally protocols and how they work as a whole. This is more conceptual of basically how you make a mesh protocol and kind of the guidelines that everyone went by. So let's talk about the problems of mesh protocol, or wireless, I mean. Most routing protocols are defined by finite connection. So you have a Cat6 cable that runs at a certain length. If it runs too long, it doesn't work. So they kind of assume that it's always going to work or not going to work. And then with wireless, you have a lot of variables in there, outside weather, radio signals in the same frequency that kind of jam it. So you have all these different things that gives the link quality a very sporadic behavior. And the other thing is with wireless technology, you also have mobile devices, things that move around. So you can't assume that this connection is always going to be stable, it's always going to be connected, and that becomes kind of an issue. And then you also have to understand the difference between, because this is how mesh works versus your standard home router. When you go to your home router, it's an access point station combo. You basically have one dedicated device that broadcasts out, and you have all the clients communicating to it. Ad hoc, or the mesh technology, is entirely different. It's going to be more of the decentralized approach. So every node has its own ability to understand what the routing table is, its nearest neighbors, and where to take the data and move it. But if one of the nodes drop, it's not game over. The other neighbors by will redirect the traffic around it. So that's essentially how mesh networking works. So, anybody watches Walking Dead? So a network engineer went to the doctor, shut up, Dad. He told the doctor, it hurts when I pee. It hurts when I pee, Carl. The biggest problem when deploying or developing a networking protocol is that you can't assume that traffic is always going to be one type of traffic. You have many different types of traffic. You have UDP traffic, you have TCP traffic, ICMP traffic, echo requests, hello. You have UDP traffic, multicast, unicast, broadcast, anycast, which I actually learned about recently. And then you also have UDP traffic. If anybody noticed, I repeated UDP 3 times, because essentially UDP traffic is the honey badger of networking protocols. It just doesn't give a shit. So these are the types of wireless mesh networking protocols, or your ad hoc networking. So you got proactive, which contains a fresh, smooth babyface list of all of your destination routes. So basically, the problem is that you have a big routing table that everything's current, but as soon as one node goes down, you have to then update all of your nodes, which is kind of standard. It's not as bad, but when you have something in a wireless mesh network that constantly have things drop in and out, it causes a lot of havoc for the routing tables and whatnot. Types of proactive is optimized link state routing, Babel, DSDV, and OSPF. Reactive is a kind of another approach. Basically, every time a packet is sent, it updates the actual routes on the fly. And it creates a lot of excess flooding of network traffic, but these are really good for sensor networks. So things that aren't going to be awake all the time, that's kind of what they're designed for. So your types of reactive are your DSR, ADOV, and these are, I think ADOV is a Cisco-based one, and then your hybrid wireless mesh protocol, which is actually what is used in 802.11s. Suboptimal. So, and there's my Pokemon reference. So suboptimal is basically something that doesn't really necessarily fit in both of those categories, which is actually like zone routing protocol, which is a hybrid, and Batman. Now to talk about more of the open source movement on that of the mesh protocols. Open source community ended up, they developed more of the database. There's some other mesh protocols that are more sensor based, but to move a lot of data to be connected to a grid, this project called, well, it's more of a grassroots movement called Freifunk. It's a German for free radio. Was kind of developed as initially as a hobby, but it kind of grew into more of a activist move to basically promote a free internet, since there was a lot of censoring and blocking at that time. And then it kind of spun up a few different projects. You got one right here, which was the earliest one, OSLR, which is Optimized Link State Routing Protocol. And there's the RFC number and all that. It was designed to be initially something that didn't have link quality state, which was added later. It has multi-point relays, so basically every hop basically looks out, it kind of tells where the hops go, and the kind of consensus through that. It was one of the earliest ones, and it was kind of developed and kind of hosh-posh together. So at that time, there was another group that wanted to make a better approach, and Batman literally stands for Better Approach to Mobile Ad Hoc Networking. Clever ways that people make acronyms. And Batman, there it is, was designed in 2008 to be a replacement of OSLR. Routing tables are kind of more clever on here. They don't have because OSLR has, it's proactive, so it has all the nodes individually have the whole routing table. This one only has the routing table for its nearest neighbors. So when it reaches out to its nearest neighbor, the nearest neighbor knows what the best route is, and it goes from there. So it doesn't create a huge table for that. So no single node has all the routing tables. Initially, it was, or still is, a kind of just a draft for the RFC, but there's been a lot of development in it. It's heavily changed upon the routing protocol and experimented. They ended up originally having a layer 3 support, which most of the routing protocols have, but they wanted to go more into the data link layer. So they ended up going to layer 2. And in order to do that, to be more efficient, they ended up getting approved to be supported by the Linux kernel. So instead of having your commands go more into your user space and then come back for requests for networking, it's all on the kernel level and at the level 2 of that. So some of these features, and it keeps growing. The only reason why it's still considered experimental is that they're still adopting new ways of that, but by far one of the best mesh protocols out there. But here's some of the new features that they constantly add. Allows basically a gateway server, so broadcast domain, so you could actually tell that all these nodes in this area have a broadcast domain going over to there, and then it goes to that gateway for the internet, and the other ones over here have that. So you can actually isolate traffic a lot better and have more control of that. Bridge loop avoidance, it's basically, if you use Cisco equipment, it's STP, but it also incorporates more the, I guess, more of the link quality and a bunch of other things inside the packet itself for better destination of looping. IP isolation, so you have the ability to have your mesh nodes not be able to communicate to other mesh nodes. So the only way they communicate is by going back to the gateway. So it keeps things a little bit more secure by doing that. Multicast optimization. So if you're basically doing a multicast, it's not going to flood everything. It's only going to actually go back to the gateway, and the gateway knows where to actually redirect it. It's kind of interesting how they have that set up. Multi-link optimization. A lot of these wireless devices that they develop will have multiple radios on them. So they actually utilize one radio for bandwidth and also the other one for another set of bandwidth, and they kind of optimize that properly. And network coding is kind of a cool concept they did. Basically, they increased the throughput of the packets by basically kind of creating a relay. So instead of sending out packets all the time straight away, like there's milliseconds of change, but they basically use kind of clever relay methods of that to send packets as one big thing with it all together. So you increase your throughput a lot that way. Babel is another one. So Babel was created in 2011. It was a combination of a lot of different ideas from previous mesh protocols. The name of it is super long. You have a loop avoidance distance vector routing protocol. A combination of like a Cisco format, two other ones, I forget what they were. But it's designed to be very robust and have extremely fast conversion. So when you need to update the routing tables, it had the best ability for that. And it's part of the Quag routing suite. So it's most of your Linux routers, it's already built into that. And then OSLR v2. So they ended up updating the OSLR RFC, and they kind of made it more standardized. It's part of standard track, so it's not experimental anymore. It's flexible and modular. That's the other feature they added. And it's also backed by a lot of larger corporations and military related too. So I'm going to go with questions, but before I do that though, my Twitter handle is up there. Sorry for the small font. It's Alex_S_Cod. If you have any interest of installing aftermarket firmware on a router, I'm going to be doing a class at BSides Cleveland on June 24th, possibly at Circle CityCon. But go ahead and open up for questions if anybody has them. I know it's kind of getting late and I'm the last talker, so if you want to wrap that up, let me know. So any questions though for that?
Go back to the previous slide.
This one?
Yep.
Okay.
So have you installed any of this on Raspberry Pi or anything else, or only on routers?
You can do it on Raspberry Pis too. OpenWRT, I believe they have a package for that. Raspberry Pi is just an ARM processor, and there is ARM support on the OpenWRT platform. I'm not sure about the other distro, so. Go ahead.
You didn't mention Commotion Wireless at all. Do you have any experience with Commotion Wireless?
No. Yeah. What's Commotion Wireless in?
Oh, it's a. I guess we can talk later about
Okay.
it. It's a mesh networking kind of out-of-box thing.
Okay. Is it its own protocol, or is it kind of like a package type of deal? Okay. Yeah, that one that I mentioned, Robin, was kind of developed for a while. It incorporated OSLR and Batman together, but the project died out. A lot of these mesh packages that I've seen will last for like a couple of years, and they realize that there's not enough people for the movement, so they kind of die out. Most mesh protocols, they ended up are just like slapped on top of OpenWRT, and people do their own thing with that. And OpenWRT, I forgot to mention, is I like them a lot because they follow more the Bazaar and Cathedral methodology, which is part of the kind of the free software movement or the open source movement. So they basically keep everything minimalized as possible. So a lot of these router firmwares will have all this stuff that you don't really care about, and you could just install the base OpenWRT and add all the packages separately. Any other questions? Okay. All right. You guys have a good night.